Today we are going to go over 9.5 part 2. How do you find intersections between polar curves? So the point of intersection is very similar to rectangular system, but it's slightly different. Let me have a look at this example. How do we find the point intersection of R1 and R2? Similar, we solve system equation, we set them equal to each other. So 1 minus 2 cosine equals 1, give us cosine theta equals 0. So cosine theta equals 0, theta equals pi over 2 and 3 pi over 2. So the 2 points we have will be 1 pi over 2 and 1 3 pi over 2. This is from the system equations. And but if we plot these two functions, r equals 1 minus 2 cosine and r equals 1, we can clearly see there are 3 points of intersections. We solve for A and B, we are missing this one. It's because this doesn't show up in the equations because when r equals 1, if you look at r equals 1, the point occurs with coordinates when pi theta equals pi. When theta equals pi, the point will get here. However, for this equation, when theta equals 0, r equals negative 1. When theta equals 0, r equals negative 1. So when we plot it, we have to go to the opposite direction. That's where it gets this point. One r is negative 1, one is positive 1. So we have to look at the picture and check. And also sometimes when we talk about the zeros, sometimes we have to be very careful because 0 pi, 0 10 degrees, doesn't matter what's the angle here. As long as r equals 0, it will be the origin. So when we have intersection there, you have to be very careful. You have to check what's going on there. Let's see some examples. How do we solve these examples by hand or by graphing calculator? For the first one, we set them equal. So 1 plus cosine equals 1 minus cosine. So cosine theta equals 0. Theta equals pi over 2 and 3 pi over 2. So we will plug pi over 2 in, give us cosine pi over 2 is 0. So it's 1 pi over 2 and 1 3 pi over 2. So this gives us point A and point B. However, we have another intersection at r equals 0. So if we set r1 equals 0, so cosine theta equals negative 1. So theta equals pi. So this is 0 pi. And if we set r2 equals 0, cosine theta equals 1. This gives us theta equals 0. So this point will be theta equals 0 and r equals 0. So both these 2 points describe the same point in the rectangular system. Same point, 0, 0. And this is in rectangular system. And this is in polar. So this is our theta here. So let's have a look at part D. I'm going to change the equation to r equals 2 minus 3 times cosine 3 theta and r equals cosine theta. This one I'm going to show you how do we use graphing calculator to solve this problem. So first of all, we plot these two functions in polar. Let's have a look. This is the graph for polar equations. If you look at here, we have 1, 2, 3, 4, 5, 6, 7 intersections. Okay, let's look at the rectangular equation. So when we plot this, so if we want to solve for the intersections, we set 2 minus 3 cosine 3 theta equals cosine theta. We are going to plot y1, y2 in rectangular system. We treat theta as x. When we graph it, let's set up a window, 0 to 2 pi in this case. So we have 1, 2, 3, 4, 5, 6 solutions. And we are missing the when r equals 0. That's exactly what we are looking for. You can find the solutions for each one. Theta equals this one theta equals 5.57, 1.57, 2.57, 3.7. Okay, you can compare your answers with mine and finish the rest of the problems.